Hello, welcome to the Oxford Maths Admissions Test for 2018. This is question 1, part E. A circle of radius 2 centred on the origin is drawn on a grid of points with integer coordinates. Let n be the number of grid points that lie within or on the circle. What is the smallest amount the radius needs to increase by for there to be 2n minus 5 grid points within or on the circle? A, B, C, D or E. So we're told that we've got an integer grid, so we can just draw our integer grid here. Radius 2, so something like that would make sense. In fact, I'm going to do it this way. I'm going to draw my circle first, and then I'm going to draw my grid around the circle. So there's 1, there's 2, there's 1, 2. So by drawing this grid, we'll actually come up with a solution that we can pretty much see the answer to, rather than having to do any complex maths. So it's always a good idea to draw something out if we're given a question that you're able to draw out, and sometimes the answer will just pop out. And as we'll see here, it's actually quite a nice simple question when you break it down. When you've got a picture in front of you, that just helps so much more. So here's our circle of radius 2 centred on the origin. Here's our grid of integer points, and let n be the number of grid points that lie within or on the circle. So we can just count up these points that lie within or on the circle. There's obviously 1, 2, 3, 4 integer points that lie on the circle, and there's just this 3 by 3 square of integer points that lie within the circle, so that's obviously 9. 4 plus 9 is 13, so the number of points n that live within or on the circle is 13. We can then work out 2n minus 5, so 2 times 13 minus 5 is just 26 minus 5, which is just equal to 21. So we're looking for an increase up to 21. So that's actually an increase 21 minus 13 of 8. So we're looking for the next 8 points that we can swallow up as this circle increases. And if you look carefully, I'll do this in green, you can see there's 1, 2, 3, 4, 5, 6, 7, 8 points that lie just outside the circle. So actually what this question is asking us is, what is this distance? And obviously we will know the radius, so we can work out just the tiny little distance that the circle needs to increase by to actually get these points onto the radius. So we can do that now. Obviously this distance is 2, this distance is 1. Using Pythagoras' theorem, we know that h squared is equal to 2 squared plus 1 squared, which is just 5. So h squared equals 5, which obviously implies that h is equal to the square root of 5. Straight away, root 5, we know where this answer is going, so I'd be looking up here and looking at the selection of answers there are. This is the only one with root 5 in, so this is probably the answer I'd pick at this point. Obviously we want to save as much time in the exam as possible and get on to the next questions. However, just for completeness, I will carry on with the question. So we know this whole distance here is root 5. We know the radius is just 2, so the increase will be root 5 minus 2 equals the increase that we're looking for. So there we go. The answer is part A. I hope that's been a help. If it has, please leave a like, comment and subscribe. If it hasn't helped or it's not been quite clear enough, please just comment down below and I'll consider remaking the video, or I'll just try and answer your question in the comments. Thank you very much for watching and keep up the hard work.